IDC Virtual Classroom. I am Tanuj Mathur and today we are going to study pointers. So as the name suggests, pointers, something which points to something. So let's fill these somethings with the data types and the variables. So a pointer is a type of a variable that points to another variable. So now let's learn what are variables. Variables are nothing but entities that hold some space in the memory. So this is a memory block of one variable. This is a memory block of another variable. So this is a pointer as it points to the another variable. Now how does this variable points to this? So let's see. A variable that holds the memory address of another variable is a pointer. I am writing it in short form. Pointer is a pointer. So the memory address of this variable will be stored in this. Say it's some hexadecimal value which will be stored in this. So now let's discuss the declaration syntax of pointer. Nothing, it's general case of C++, how we declare a variable. We write the data type say integer. For instance, name of the variable say A and semicolons. This is how you declare. Now if we want to declare this as an integer pointer, we will declare it as int star A. So this is an integer pointer which will hold a hexadecimal address of an integer variable. So now let me generalize this as return data type star ptr name of the pointer. So the special symbol star is used to declare a pointer. Now I want to discuss about another character, ampersand. The ampersand is an operator which returns the address of a variable. Say we have an integer variable b. We use and b. So and b will return the hexadecimal value of b. So what does this function? This can be thought of as address of. So address of b is some hexadecimal value which will be reflected with the help of this operation. So now I want to store the address of b into the pointer we created, that is star a, that is a. So now since int star a we have declared it, we will use a, which is the pointer, equal to and b. So what this will do is the memory address of b will be stored in a. So when we will access a, it will point to b, the value of b. So now if I want to print the value of a, so print f %d comma %d comma a star a, this will print the value which is in the b. That is, say if we initialized b with 10, it will display 10. But now if I print just a, it will print the address of b which is stored in a. So this is the general use of pointers, to actually store the address of another variable. There can be pointers to pointers too. So pointers which point to a pointer which actually point to another variable. So there can be many such combinations. So I would like to discuss that these data type can be of any, say int, integer, character, float, double. So what is the difference in the pointers with different data type? They all store hexadecimal value. Then what is the difference? The difference is the value which they point to are different. So when we say print star A, in this case we printed star A. If our B variable was of different data type and our pointer was of different data type, it would have printed that corresponding data type. Say it was, if it was float, it would have printed 10.00. So the actual implementation, the value it is storing is hexadecimal, but the value it is reflecting is float in this case and integer in that. So this is the difference. If we use different data type, the reflecting value is different, not the value it has stored. It's still hexadecimal, but it is different value which it points to. So now let's discuss what are null pointers. If our pointer, say A, does not point to anything, then it can be a fatal pointer and it can create a fatal error. So to avoid this, if we don't have an initialized pointer, we can initialize it with null. That is with nothing, during the declaration statement. So how we have to declare a null pointer is int star A equal to null. So this will point to nothing, and hence this will not point to anything, but still it is initialized with null. So it will not create a problem. Now it is always a good habit to initialize it with null to avoid such fatal errors. So now we'll study the concept and descriptions, like the types of concepts pointers can be used in. So let's start with pointer arithmetic. So we can perform certain arithmetic operations on pointers. Say we have a pointer PTR. We can use the increment, decrement, addition and subtraction. So let's do it. PTR is the pointer here. Now it is holding an hexadecimal value. Now if we increment plus plus, it will move to the second memory block. Say this is our memory block and this is PTR pointing. Say it is pointing to 100th location right now, and this is integer block. So if we execute plus plus PTR, what it will do, it will move to the second block, that is 102. Because it holds 2 bytes, the next block will start from 102. So it is the 102nd block, second block that it will be using. So now the pointer reflects to this after getting incremented. If we want to increment the value that pointer points to, we'll use star PTR plus plus. So what this will do is, say star PTR points to B, where B holds say 10. So now star PTR plus plus will increment the value of B to 11. So this is the pointer arithmetic. The next concept we'll study is array of pointers. So now, as the name suggests, we can create an array that is collection of similar data type in sequential order of pointers. So all the data types will be of pointer type. So say integer is our data type, star PTR, and the size of the array. So what will happen is, say this is our array of pointers. Say here's one pointer, another pointer, so what will happen is, each block will point to a separate value, or each block will hold a different hexadecimal value which it points to. So say we have another array B of the same size. Say our keyword here identifier is size. So now PTR is of the same size, B is of the same size. Now let's use a for loop. I equal to 0, I less than size, I plus plus. Now let's initialize the pointer with this array. So for int I equal to 0, I less than size, I plus plus ptr I ampersand bi semicolon. Always make sure that you use a semicolon because it will create an error if you don't use that. Okay, so now ptr I equal to and b of I, address of b of I. So if it is 100, this is 102, this is 104, this is 106, this is 108, this is 110. So now for the first time when the loop gets executed for ptr 0, b of 0 executes. It gets the hexadecimal value of b of 0. So here the value of b of 0 will be stored. The next loop ptr1 will have the value of b1, here stored hexadecimal, hexadecimal, hexadecimal. This is how this pointer array is executed. And for a fact that every array is a pointer itself. Let me tell you a fact that an array is declared in this format, say int array 10. The name of the array is itself a pointer. So the name array is a pointer, and we can do the array arithmetic and array operations, pointer arithmetic and pointer operations on the array, as array name itself is always a pointer. So let's now discuss the pointer to a pointer. Say there's a pointer p, there's a variable b, and there is another pointer to a pointer ptr. So a pointer to a pointer is declared in such way: int, say integer pointer of pointer ptr. So this pointer will point to p. If p is declared in this form star p, then and int b is the variable. So p equal to and b. P points to b and ptr points to and p. So now ptr pointer will point to p and p will point to b. So this is the concept of pointer to pointer. So now I have discussed the major concepts of pointer and the most useful concepts of pointers. Pointers are quite famous and are used in many computational concepts. So thank you guys for listening to me, and subscribe to the YouTube channel Virtual Classroom IEDCVC@gmail.com. Thank you.